Hello and welcome to week 1. I apologize for not being there this week, but hopefully you guys understand the notes. If not, we will go over them next week when I am back. We'll go ahead and start chapter 1. The notes are actually, and if you go to Blackboard, they're in your weekly folders, and week 1 is where you will find your notes. They should be the blank notes, and also your homework is posted in there that you will be due next week when you come back. So if you have questions, we'll go over those. So chapter 1 really talks about trigonometric functions and basic terminology. So when we get started, we say a counterclockwise rotation generates a positive measure and a clockwise rotation generates a negative measure. So we go down and we talk about complement and supplement if we scroll down here. So a complement is a 90-degree angle and a supplement is a 180-degree angle. The way I remember easily is 90 comes before 180 and C comes before S. So hopefully that's one little trick that will help you remember it. And so a complement is a 90-degree angle. So for A, we're going to take 90 minus 40, and that will give us a 50-degree angle. And for B, a supplement angle is 180 degrees. So then we would take 180 minus 40, and that would leave us with a 140-degree angle. Your next question, as we look down here, it says, reflect for any angle by how many degrees does a supplement differ from its complement? Well, we know that a supplement is 180 degrees and a complement is 90 degrees, so the difference is going to be 90 degrees. If we go ahead and flip to the next page and go down, it says find the measure of each marked angle in the figure. Well, we know that this is a 90-degree angle, so this is a complementary, this is a complementary angle. So complementary angle is 90 degrees. So here we're going to take 6x plus 3x equals 90 degrees. So we combine our like terms and we end up with 9x equals 90 degrees. So if we divide both sides by 9, then we end up with x equals 10. If we plug that back in here, we have 6 times 10 plus 3 times 10, which gives us 60 plus 30, which gives us our 90 degrees. So we know that we are correct. I apologize for this not being very neat. It's hard to write with a stylus. So let's go back over to this one on B, and B is a supplementary angle. We know a supplementary angle is 180 degrees. So we have to combine our two like terms. So we have 4x plus 6x equals 180. So we end up with 10x equals 180. If we divide both sides by 10, then we end up with x equals 18. If we want to check our work, we can take 4 times 18 here, plus we have 6 times 18 has to equal 180 degrees. Well, 4 times 18 is 72, plus 6 times 18 is 108, which then will give us 180 degrees. As we look at our next section, it says calculate with degrees, minutes, and seconds. So what we need to do is add our like terms. So here we have 51 degrees and 29 minutes plus 32 degrees and 46 minutes. So I'm going to set that up, 51 degrees, 29 minutes plus 32 degrees, 46 minutes. We just add them together. So here we're going to add our minutes together, which is our right side. So 29 plus 46 is going to give us 75 minutes. Then I'm going to add my degrees, and 51 plus 32 is going to be our 83 degrees. So now what we can do is we can rewrite that, because 75 minutes, if we talk about minutes, if we take 75 minus 60, that gives us 15 minutes, correct? We know that this 60 here is actually 1 minute. So what we can do is we can take that 1 minute and we can add it over here to this, and then we would end up with 84 minutes, because that 1 minute can take our 60 seconds, and then we have 15 minutes, or 60 minutes, an hour, excuse me, would give us 1 degree. So we can rewrite that as 84 degrees and 15 minutes. Next, if we go over here, we have 90 degrees minus 73 degrees and 12 minutes. Well, we can't keep that 90 because we're going to have to borrow because we don't have any minutes there. So our 90 actually becomes 89 degrees and 60 minutes. So we're really just borrowing. And then we're going to subtract 73 degrees and 12 minutes. So if we take 60 minus 12, that will leave us with 48 minutes. And 89 minus 73 would leave us with 16 degrees. So the final answer for there would be 16 degrees and 48 minutes. And because 48 is less than 60, we do not have to change anything on that one. So it says go down and reflect. It says how many seconds are in 1 minute or 1 degree, which we talked about in example A there, which would be 60 seconds in 1 minute here. So now if we scroll down the page, we're talking about standard position. An angle is in standard position if its vertex is at the origin and its initial side lies on the positive x-axis. The figure shows ranges of angle measures for each quadrant when theta, this is theta, is between 0 and 360 degrees. So what happens is here we're going to have an acute angle. So over here we have an acute angle. This right here, 180 degrees, is an obtuse angle. So that kind of gives you. So here we are in quadrant 1, where theta is between 0 and 90 degrees. Here we're in quadrant 2, where theta is between 90 and 180 degrees. Down here we're in quadrant 3, where theta is between 180 and 270 degrees. And here we're in quadrant 4, where theta is between 270 and 360 degrees. So quadrantal angles, it says an angle in standard position whose terminal side lies on the x-axis, which is this axis right here, or the y-axis, which is your y-axis is right here, such as angles with measures 90, 180, 270, and so on. So these are all quadrantal angles. So here's your 90, here's your 180, here's your 270, and then your 360 is your whole, here's 360 degrees. Now we're going to talk about coterminal angles. Angles with measures 60 degrees and 420 degrees have the same initial side and the same terminal side, but different amounts of rotation. Such angles are coterminal angles. And their measures different by multiple of 360 degrees. So you want to find an angle where your angle is between 0 and 360 degrees. So really here you need your angle to be between 0 and 360 degrees. Well, here we have 908 degrees. That is not between 0 and 360 degrees. So we have to find its coterminal angle. And it says find the angle of the least positive measure that are coterminal with each angle. So what we have to do is we have to take 908 degrees, excuse me, and we need to subtract 360 degrees. So if we subtract that, we know that still is not under between 0 and 360. So we're going to subtract another 360 degrees, which would bring us down to 188 degrees, which that angle is between 0 and 360 degrees. So we can say that's 188 degrees with coterminal. I'm sorry, what 188 degrees is coterminal with 908 degrees. Our next one is a negative 75. Remember, we have to have a positive. So instead of subtracting 360 degrees, we are going to add 360 degrees. So if we take negative 75 plus 360, we will get a 285 degree angle. 285 degrees then is coterminal with a negative 75 degrees. Again, we go to C, and it is a negative 800, so we're going to add 360. Well, if you think about it, it has to be positive, so really I could take 360 degrees times 3, and that will give us 1080 degrees. So then I could take 1080 plus my negative 800, and that will leave me with a 200 degree coterminal angle. Here we got to subtract an A because it was a positive. Well, in B we had negative, and C we had a negative value, so we had to add the 360 degrees. Okay, so we scroll on the page to example 6, and it says analyze revolution of a CD player. It says CD players always spin at the same speed. Suppose a player makes 480 revolutions per minute. Through how many degrees will a point on the edge of a CD move in 2 seconds? Well, we know that there are 180 degrees. Sorry, this is new for me. 180 degrees is 1 revolution. Okay, so we think about revolution. A revolution, if we start here all the way around, is 360 degrees for my 1 revolution. Okay, so it says that it has 480 revolutions per minute. So if I take 480 revolutions and divide it by 60, which is 1 minute, then it tells me that it's going to go around 8 times per second. Okay, so we know that there are 60 seconds in 1 minute. So in 2 seconds, we're going to take 2 times 8, which would equal 16. So we have 16 revolutions in 2 seconds then. So each revolution is 360 degrees. So here we have 16 revolutions, right? So we would take 16 times 360 degrees, which equals 5,760 degrees. So if we go back, we could actually do this another way also. So this is one way that you could get to your answer. Another way you could do it is there's 480 revolutions in 1 minute times 1 minute over 60 seconds times 360 degrees in 1 revolution. And you want to do that times 2 seconds because it wants to know right here how far does it move in 2 seconds. So if we would multiply all that out, we would end up with 5,760 degrees. Because if we look here, our revolutions would cancel, our minutes would cancel, and then we have our seconds. So this would be actually seconds, so our seconds here would be canceled. So we have with 5,760 degrees, because all we're left with here is degrees. So those are 2 different ways that you could find the answer to that problem. Okay, that was section 1.1. We're going to move on to 1.2 now. Angle relationships and similar triangles. The key terms here are vertical angles, parallel lines, transversal, similar triangles, congruent triangles. So vertical angles have equal measures. So let's go down here, and this is alternative interior angles. So here's your alternative interior angles. So here the measure angles are going to be equal. Okay? Because you figure if this is 180 degrees and this is 180 degrees, if you have your interior angles here, they're going to be equal because you have your transversal going through. And transversal will go through equal lines. Then if we scroll down the page here, we have alternate exterior angles, and the exterior means that they are outside angles. So also your angles 2 and 7, which if you were to go back up and look at the other example. So the angle measures here are also equal angle measures. Here we have interior angles on the same side of the transversal. So this again right here is our transversal line, and we have our 2 angles here. As you can tell, those are not equal angles. Here we have an acute angle for angle 6, and here we have an obtuse angle for angle 4. Well, because this is a transversal line, if you add angle 4 and angle 6 together, the angle measures will add up to be 180 degrees. Here we have corresponding angles. So again, we have our transversal, and we have angle 2 and angle 6. Well, if you look, those look to be approximately the same size, which they should be because of the transversal on the line. So there, the corresponding angles are also measured equally. Okay, if we look here, it says find the measures of angle 1, 2, 3, and 4 in the figure given. The lines M and N are parallel. Well, if you look here, we have angle 1 and angle 4, which are alternating exterior angles. And if you look on the previous page where we talked about alternating exterior angles, you would know that these angles are equal. So we go to solve this, we can say 3x plus 2 equals 5x minus 40. So what I'm going to do first is we have to set these equal to each other. So I'm going to add 40 to both sides. So here then I would have 3x plus 42 equals 5x. In reality, you could have subtracted 3x from both sides, subtracted 2, subtracted 5x, it doesn't matter. Okay, so now the way I'm doing it, I'm going to go ahead and I'm going to subtract 3x from both sides next. So then these would cancel out, and I would have 42 equals 2x. So then next I would divide both sides by 2. And so I would have x equals 21. So then what I can do is I can take that and I can plug that back into my equations. So over here, if I say 3 times 21, because I know that x equals 21 here, plus 2, if I take 3 times 21, that's going to give me 63 plus 2. So angle 1 equals 65 degrees. Then if I go over here, I'd have 5 times my x, which again is 21. So 5 times 21 minus 40, and 5 times 21 is 105 minus 40, so angle 4 is 65 degrees. So if you look here, sorry about the messiness, they both will equal 65 degrees. So now we have found angle 1 and angle 4. We have to find angle 2 yet, and we have to find angle 3. So I know that here, this is 180 degrees, correct? So here I could take 180 minus, I know that this right here is 65, which then would leave me 115 degrees. So angle 2 is 115 degrees. And now we have to find angle 3. Well, angle 3, whoops, wrong way, sorry. Angle 3 is a vertical angle to angle 1. And our angle 1, if you look here, these are vertical angles. And so if angle 3 is vertical to angle 1, it has to be also 65 degrees. So now we're going to talk about angle sum of a triangle. The sum of the measures of the angles of any triangle is 180 degrees. It says apply the angle sum of a triangle property. The measure of two of the angles of a triangle are 48 degrees and 61 degrees. Find the measure of the third angle, x. So what I'm going to do, I'm a visual person, I'm going to draw a triangle here. And so I'm going to say I have 48 degrees here, I have 61 degrees here, and I have x here. And we know that a triangle sum, the angles all equal 180 degrees. So I'm going to take angle 48 degrees plus my 61 degree angle plus my x, and I have to set that equal to 180 degrees. If I combine my two terms here, 48 plus 61 gives me 109 plus my x, my unknown, is 180 degrees. So if I subtract 109 from both sides, this cancels out, so I know that x equals 71 degrees. So if you were to plug 71 in back here and add them, 71 plus 48 plus 61 should equal 180 degrees. So you know then that you have solved it correctly. The next one says, can the angles, if we go to reflect right here, it says, can the angles of a triangle be 60, 70, and 80? Explain. So what we're going to do, if we add 60 plus 70 plus 80, if we add all those together, that equals my x value. Well, if I add them all together, 210 equals x. Well, can this be a triangle? No. Why not? Because a triangle has to equal 180 degrees. It cannot equal 210 degrees. So now if we go down, we look at our different types of angles right here. We have all acute, and so if we have all acute right here, this is an, because we have an acute angle here, an acute angle here, and an acute angle here, this is actually an acute triangle. Here we have our 190 degree angle, so this is a right triangle. And then here we have one obtuse angle, so this is actually an obtuse triangle. If we go down here, it says all sides equal. So we have this side, and this side, so this is actually an equilateral triangle. Here I have two sides that are equal, and then I have one side that is not equal. So this is an isosceles triangle. And then here we have no side, so I have this side, and I have this side is not equal, and this side is not equal to that. So I have three different sides that are not equal, so that is a scalene triangle. Okay, now we're going to go to our next page here, and this is example 3. It says in the figure triangle ABC, which is this, oh, sorry, let's get that page back there. We have triangle ABC, which is this triangle here, and NMP are similar. So we want to find the angles of angle B and angle C. And we can find those because they tell us that they are similar triangles, which means some of the angles are equal. So if we look here, we have angle C actually compares to angle P, or corresponds, excuse me, so I could say that C corresponds to P, and the angle of P measures 104 degrees. So then C must measure 104 degrees, okay? Because right here, angle N and M are 45 degrees. So now we know that angle C is also 104 degrees because angle P here is 104 degrees. So angle B, corresponds to M, and we know that M measures 31 degrees, so then B must also equal 31 degrees. And if we want to just double check to make sure, we can add these together. So we could add 45 plus 104 plus 31, and they should all equal 180 degrees. And if we slide down our page here, it says, given that triangle ABC and triangle DFE in the figure are similar, find the lengths of the unknown sides of triangle DFE. So here we know that, if we look here, we know that A corresponds to D, or I'm sorry, A corresponds to D. And then we can say that E corresponds to C. So what we can do is we want to set this up as a proportion. So set up as proportion. So we know that here we have E corresponding to C, so I can say 8 over 16 equals, and then the other known one is we have our segment DF here corresponds to AB. So we can say that DF corresponds to AB, which is 24 degrees. And then so we can do our cross multiplying. So I can say that 8 times 24 equals 16 times DF if you cross multiply. So 8 times 24 gives us 192 equals 16 times DF. Well, if we divide both sides by 16, we can say that DF equals 12. So I know that this segment here now equals 12. Okay? And actually I said angles, but we could say the ED corresponds to CA here, which would be our 8/16. Then we have to go and we have to find our unknown, which is EF. So we can do, again, set up as a proportion. So I'm going to use, again, ED and CA. So I can say 8/16 equals our EF over our CB, which is 32. Okay? When you set up your proportions, if you're going to use this angle first, or I'm sorry, we use that second. So if we're going to use this angle second, down here, we have to make sure that we're comparing. We have to make sure that we're using this angle second here also. So set up your proportional equal. So again, we can cross multiply. So I can say 8 times 32 equals 16 times EF. So 8 times 32 gives us 256 equals 16 EF. If I divide both sides by 16, then I would end up, divide this by 16, divide this by 16, and that should come up with 16 equals my EF. So now I know here that my EF is actually 16. So now if we go on to example 5, it says, workers at the Morganza Spillway Station need to measure the height of the station flagpole. They find that at the instant when the shadow of the station is 18 meters long, the shadow of the flagpole is 99 feet long. The station is 10 meters high. Find the height of the flagpole. So what I would do is I would just draw again, draw again two just triangles as we did before and set them up as proportions. Okay, so what we're looking at is we have one that's 18 meters long and we have one that's 99 feet long. It is, I'm going to write over here for you, it's okay to have different units of measure when doing proportions. Okay? So here, even though we have meters and feet, that's still okay. So we're going to set this up, and I'm going to say that this is M and this is N. So what I'm going to do, and it tells me that this one is 10 meters high. So this station here is 10 meters high. So then M and N, this is our unknown height for our flagpole. Okay? So I can say that MN, I'll write down here, MN over 10, because we're setting this proportionate to this proportionate. And then it says that we have 18 meters long. Okay, so 18 meters long compared to your 99 feet long. Okay, your 10 meters high is actually this 10 that's right here. We're talking about meters high. Okay, and we're trying to find the height of our flagpole, which would right here be X. So we have our proportion, so I can say our MN over 10, and if I use this MN first here, then I have to use this height first here. So it's going to equal 99 over my proportion here, which is 18. So then if I cross multiply, I'm going to have 10 times 99, whoops, it doesn't look like a ton, sorry. This pen doesn't write very well, equals MN times 18. And really, to make this easier on yourself, you can actually reduce this to make it easier as far as doing your multiplication. So if you think about 99 and 18, you know that 9 goes into both of these. So 9 goes into 99 11 times, and 9 goes into 18 2 times. So really, instead of writing this, you could do a little bit more mental math. So MN is going to be times 2. So MN times 2 over here, And then we're going to have 10 times 11 here. I hope that makes sense and I didn't mess you guys up. It's just easier to do mental math with smaller numbers. So then if I multiply these out, here I would have 110 is mn times 2. If I divide both sides by 2, then I would know that mn equals 55. So our flagpole is 55 feet high. And then if we scroll down the page for one more, I hope that wasn't too confusing for you guys. If I scroll down the page more, it says, in example 5, why doesn't it matter that the measurement for the station are given in meters while their measurement for the flagpole are given in feet? Well, I told you up here, if we scroll down again, I told you right here that it doesn't matter because we are dealing with proportions. So if I go back down, if I go back down my page here, why? You could say, well, because it is proportional.